Cool, right, thank you. So I'm Tim Perry, Pim Terry on Twitter, and I want to talk about TypeScript. Has anybody here ever actually used TypeScript before? Interesting, okay, a couple, great. Obviously this title is something of a dramatization of the situation, but I do have a serious point here. What I want to try and look at really is that feeling when you're writing code and you have no idea whether it's going to work. So perhaps you're using some API that you just don't know that well. Perhaps you're working in a team of people and you're calling functions that you didn't write. Perhaps you did write it last week and you've forgotten. You get into a position quite easily when writing dynamic languages like JavaScript where you're calling a function and you don't know how the API works. You're being given an object, you want to get some information out of it, and you're not sure how to do that. You pass a callback to something, you don't know what it's going to call your callback with, and you need this kind of information, and you end up digging through documentation, looking into the code frequently, hunting down unit tests, this kind of thing, trying to work out exactly how it behaves. Perhaps you play around with the REPL, see what exactly it's going to give you. Eventually you find something that works, but does it always work? Does it work in this one way? You put something together, you get some unit tests, they break, you go back and forth, and eventually you get something that is probably there. I mean, this is annoying, this is frustrating, it slows us down, it's not great, and it is avoidable. TypeScript and type checking generally helps us solve this problem much better, much quicker, and done well, lets you write code faster and more effectively. So I want to dig into this. I want to give you a bit of introduction into TypeScript, how exactly it solves these problems, how it's going to make your life better, and maybe convince you that it's worth having a try for your next Node JavaScript project. A little bit of context to start. So I work for Softwire. We're a bespoke software development company in North London and Bristol. We build everything for everybody, including a lot of JavaScript and a lot of Node, for people like Cisco and the BBC and loads of other people you've never heard of. And we've been starting to try out TypeScript on some of these JavaScript projects as a way of managing the complexity. When you're building bigger and bigger stuff, when you've got systems with more and more structure, you need to be able to understand that, you need to be able to work with that, you need to be able to quickly manage that through teams of people. So this is kind of the direction we're coming from for this. I would be remiss if I didn't point out that we are also recruiting for anybody smart at all, with any level of experience. We're just looking for very clever people who want to be really good developers. And if you're not very smart, we're also doing training courses. So if you're interested in that kind of thing, take a look at our website or come and talk to me straight after this or just in the pub or whatever. But what I'm actually here to talk about is TypeScript. So TypeScript is JavaScript with types, in short. It's a superset of JavaScript. So any JavaScript you write is already valid TypeScript. And then it gives you extensions on top of that. These extensions provide you with static typing. It's a compiler that compiles to JavaScript and along the way checks that your code is not fundamentally structurally broken. This is optional typing, so unlike languages like Java or C#, you don't have to put a type on absolutely everything. You can just write normal JavaScript and opt out of the type checking, except in the few cases where you need it, this kind of thing. And it's also inferred type checking. Rather than having to specify types everywhere, the TypeScript engine understands the code you're writing, understands the thing you're interacting with, and has an idea of the types that are already there, and can work out the types for most of your code all on its own without you doing anything. You can then annotate extra types to get more and more of that if that's useful, or for free, you can just get type checking across loads of your code base for no effort. This is quite good. I think this sounds quite exciting. I'm going to try and convince everybody of that. The main reason this sounds quite exciting, hopefully that's readable, is that dynamic typing is lovely up to a point, but doesn't really scale necessarily in a lot of cases. Your code still has types with dynamic typing. You're calling a function that expects a function that takes a certain kind of parameter and its callback. You're getting an object and you need certain properties to exist there and you need some of them to be booleans and some of them to be strings. And all these types are still there. It's just nobody's written them down and you have to remember all of them all the time. That's worse. You're not very good at that. Computers are very good at that. You can delegate this whole problem to computers. You can get them to give you that information at exactly the moment when you need it. You can make it much easier to get at that information, and you can get them to automatically check all of that information every time you do anything. You can think of this as documentation for all your code that is guaranteed to be up to date, gives you a basic idea of everything that's going on, and gets automatically checked so that you can't go against it. Automatically, everything, nice and safe, structured, easy to understand. To make this a little bit more convincing, I've got a nice example. This is some JavaScript code for a browser that gets the current location, checks it's recent, as in it's in the last year, sticks it in a div and puts it on the page if it is, and otherwise gets rid of some messages from the page if it's not. and does this without using high accuracy, so not enabling GPS. And the actual functionality of this doesn't particularly matter, except for the fact that this is riddled with bugs. This code on almost every single line doesn't work. I'm quite interested if anybody can see that many bugs in here, if people can spot all the various bits of problems. TypeScript catches essentially all of these out of the box. This is vanilla JavaScript. We're not doing any types on here. Just type inference alone will catch a whole selection of bugs. Things like JS hint, JS lint, if you're using them, won't. There's lots of stuff where you need to understand the types to be able to see this go wrong. And we can demonstrate this. If we copy this, we use the TypeScript playground, which is a TypeScript compiler running entirely client-side inside a browser, just as a way of demoing TypeScript. We just paste it in. It compiles in sub-second times and points out that all these things are broken. You cannot go position.latitude. That does not exist. Date.parse takes a string, not a number, and if you provide a number, it will just return not a number and break the rest of our code. GetYear is not a thing that exists, class does not exist, style is an object you have to assign properties to, text does not exist, append is actually append node. And you're not allowed to do for each on node lists because they're actually really arrays. And even if you were, once we fix this, it'll point out the display has to be a string. This final argument here, you're not allowed to provide unless you've also provided an error callback anyway, and actually never is a Boolean, so here never is truthy, and therefore this is true and turns on your GPS. All of this is very broken. This is clearly wrong, and you get instant feedback if you'd actually written this in TypeScript to start with, and you'd know it was immediately wrong. In addition to being told it's immediately wrong, it makes it... Oh, bugger. Yes, it makes it much easier to actually do well in the first place. So we type position, and I type dot, and it knows everything I could possibly want to do. TypeScript knows what a position is, and the only thing I can want to do with a position is get the chords or get the timestamp, because everything else is invalid. There's nothing else that a position can give me, so I want to get the chords, and actually, these are all the things I could possibly get about a location. So it's chords.latitude, not .latitude. And this is because it already understands these types. This information is there, available, the computer has got it, and it could just give it to me at exactly the moment I want, and similarly give me bits of documentation, as you may have seen there. This works in the TypeScript playground, which is obviously kind of a demo for this, but also works with plugins in Sublime and Atom and IntelliJ and Visual Studio Code, the new editor Microsoft have put together that runs on Windows and Mac and Linux, and probably a whole bunch of other places, also Vim. Anywhere you could ever really want to write TypeScript, you can get this kind of stuff. And this is not even using the syntactic features of TypeScript at all. We're just running it through the compiler. And by doing so, it makes it easier to write code. And when we do it wrong, you get instant feedback. You don't run some unit tests and then try and work out why this is failing and, oh, that means this line, or get to production, you end up with undefined in some weird place. You are guaranteed that your program is structurally correct. You've got a baseline if it's not totally broken immediately, and if it is totally broken, you get exactly where it is broken immediately, straight out of the box. Hopefully this is convincingly kind of useful. All of this gets powered by type inference, as I've mentioned. The type inference engine is pretty powerful here. It's very good at detecting what your types are just because it can see what you're doing with these objects. It's obviously doing that from some baseline of type information. The reason it knows that this position is a position is because it knows what the getCurrentPosition API looks like. It already understands the built-in APIs in the browser, which means you don't have to, up to a point. It does this by having a whole set of type definitions built in. So TypeScript ships with type definitions for all the core language features, and there's also a huge project called Definitely Typed, which provides type definitions for every other library under the sun, including all the Node ones, all of Node, all the Express, Angular, React, anything else you could really be wanting to use. And in the vast majority of cases, you just type tsd install blank, and you have type definitions for that library, and you can then just start using it, and it'll automatically just pull all the types through. And once you've done that, you don't actually need to write TypeScript at all. You can just write JavaScript and get a huge number of these benefits. TypeScript, this type inference doesn't actually cover every single case. In code like this, certainly, that is all caught by the type inference engine, but in specific cases, so if you've got a variable that you don't immediately assign to, for example, it doesn't necessarily know what type it is, and particularly function parameters, it doesn't immediately infer these. But we can start to annotate these. And to do that, looks something like this. I declare variable y, and it is a number. And then I'm allowed to assign numbers to it. I'm allowed to treat it like a number and add things to it and pass it to things that want numbers, but I'm not allowed to assign strings to it or try and read y.x or any of this kind of thing. And it'll automatically check this for me. And similarly, I can annotate functions. So here I have a function say hello to, which takes a name, which is a string, and returns a string. I don't actually need to annotate the return type. That will also get inferred magically for me, so I don't have to write this here. But by putting in this return type, it checks that I've always put a return in everywhere, and that I'm always returning a string. Even if you've got complicated nested ifs, complicated switches, if you've annotated your return type to check you've returned a string, you're always returning strings. You're never returning objects. And you know that, and you've got this guarantee. You can think of it as a very, very simple, very basic unit test that gives you a bottom level of structural correctness. You're never going to write something that is total rubbish. Up to a point. This type annotations get a bit more complicated. TypeScript tries to model itself around idiomatic JavaScript as much as possible. So a lot of the way the types work is because they're expecting to type things that are normal JavaScript style constructs. So it's built around things that are sort of duck types. So you've got structural typing to kind of manage that. We've got some various other union types and sort of thing to manage other weird cases that exist in real JavaScript code, so that it's effective at typing the kind of types you see in real JavaScript. If we want some slightly more complicated annotations, you can say a callback is a function that takes an event and returns a Boolean, perhaps. This person is an object with a name property that is a string and an age property that is a number. Lots of strings is an array of strings. String or number is either a string or a number. And no idea is any. And any is a particularly interesting case here. Anything where TypeScript can't infer what the type is gets given the any type. And anything where you explicitly say it is the any type gets given the any type. And this opts out of type checking. So if at any point you get annoyed with the TypeScript thing complaining at you, typically because you're trying to do something a little bit crazy and it thinks it's a bad idea, you can just mark something as any, and the types, you opt out completely. This variable, you're allowed to do whatever you like with it. Any functions you call on it return any, and you can do whatever you like with the properties of that. And you can take sections out of the type system, essentially, and do whatever you like with them. This works pretty well, doesn't necessarily scale. If we have types like this, for example, it's a bit of a mess. Greeter is an object with a hello property that takes a name that is a string and returns a string, and a bye property that takes a name that is a string and returns a string, and a language property that is a string, which doesn't quite roll off the tongue. So this, particularly if you've got lots of variables with the same type, you've got functions that take these objects. This is not necessarily that easy to read, easy to follow, but we can build abstractions over the top of this. And the canonical way of doing that is by defining interfaces in a very similar way to what you might have seen in other big OO languages. So here, this defines exactly the same type as an interface, giving it a name, greeter with a capital G, which we can go and use everywhere else. Notably, all of this compiles away. When this actually compiles, it's just var greeter. That is the output. And everything else is just used for checking at compile time. If I ever try to go greeter.goodbye instead of bye, I'll immediately realize that I'm stupid and that's wrong. And if I ever try and assign numbers to this, it's going to break other code and it won't let me, this kind of thing. If I were doing something like this, I'd probably want implementations of greeter. I might want to define a constructor that makes a greeter and probably stick hello and bye methods on its prototype. You could do that by just doing that in a canonical way. TypeScript actually has quite good ES6 or ES 2015, as it's now called, and I keep forgetting. Quite good, yeah, ES6 support, including classes, which look like this, if you haven't seen them before. They compile, there on the left, they compile to what's on the right, and are exactly equivalent to what's on the right. This lets you define an actual object, lets you define a constructor that you can now make. TypeScript hooks into these class definitions and also defines a new type with it. So this is equivalent to defining the implementation, and they're also defining the same interface we had in the previous slide. So now we can say things are greeters. And again, this is TypeScript hooking in types so that you don't actually have to do any extra work at all. If you're defining a constructor for an object in this nice syntax, you define it in exactly the same way you would anywhere that supported ES6 already. And out of the box, type checking magically works. I've put :greeter to specify the type at the very bottom here, but I don't actually have to. That would get inferred anyway. This is optional. If you've never seen static typing before, it might be scary. It's lovely, but it looks scary. You don't have to do this immediately. You can start writing TypeScript, just writing normal JavaScript with nothing different whatsoever, and then start progressively opting into it as you like once you realize that actually it's really nice being able to get all your documentation and know that stuff is working straight out of the box instantly. But you don't have to. You can start off without that and you can progressively build it in. And if you do that, you get all the type inference stuff in all the cases where that works, and you also get the other exciting features, such as generally really good support for ES 2015/ES6. This is a whole talk in itself, which I definitely do not have time for, but there's a lot of really cool stuff coming in ES6, ES 2015. including all the various things on here. Modules and classes are particularly notable in this case because both of them hook really nicely into the TypeScript type system, and stuff will start magically working for you just because you're using the new magical features. And we get promises, and we get default parameters, and we get Unicode support, and we get all sorts of delightful things that make stuff much better and solve lots of problems you've had with JavaScript for ages. Arrow functions do this in the way that everybody except JavaScript developers would expect, for example. And stuff just gets better by using all of this. So TypeScript has fairly good support for this when you're compiling to an environment that already supports it. So it's not going to hold you back from using TypeScript, from using ES6 if you're shipping to an environment that takes that. And it's actually ahead of IOJS and Chrome and only a bit behind Firefox and Edge. So you're in a pretty good place there. If you want to start writing this stuff because you're running in really modern environments and modern browsers, you're in a good way. Or if you're putting in polyfills like core.js here. But we can actually do even better than that, joyously. And we can compile this stuff backwards. Because we're adding a compile step in, we can do whatever we like, and you can start using new fancy features that aren't supported in the slightly old, terrible browser engines or node engines that you're using, and have those compiled back into ES5 or even ES3 code so that you can run them in really, really terrible environments. And you can get arrow functions, you can do destructuring and spread, and for of, and let const, and string interpolation, and so on. It just compiles straight across here. Let const are particularly interesting. People won't have seen these. Let changes variable declaration to work in the way that everybody except a JavaScript developer would expect. And const defines variables that you're not allowed to change. In both cases here, they compile to var because you can actually check for correct uses of both of those entirely at compile time. So we don't even need them at runtime. We can just check up front that you've never done anything wrong. All of this lets you get new features very, very quickly, lets you do exciting stuff. And just dropping TypeScript in, even if you just want to use JavaScript, gives you exciting new features, exciting new superpowers, and type inference and types, and puts you in a place where if you want to start statically typing things because you're scared of stuff being broken or you just want that extra power because you like it, you're in a really good place to just start progressively bring that in wherever that's useful. There's other exciting stuff coming too, to start wrapping up a little bit here. So generators, particularly from ES 2015, are very exciting. If anybody's ever written Python, they're basically the same as they work in Python or C#, I think. So this brings in a lot of nice power for defining kind of all sorts of crazy things that produce values, iterable things that aren't just lists. The type system is also getting more and more powerful to describe more and more weird JavaScript libraries. Classes system is getting more powerful to pull in features from all sorts of other big OO languages. JSX is coming in. This is one notable feature if you're writing loads of React code. There is currently no JSX support, but that's coming in the next version, 1.6. Async and await is coming a bit later and is amazing. It's part of the ES 2016 or ES7 spec that is almost promises on steroids, essentially. It's ludicrously powerful and coming in particularly from C#. And then built-in module bundling so that as you compile, your modules get automatically bundled and you no longer ever have to think about that again, which would be nice. I'm being very positive. It's very exciting. We've used it a lot. It's very lovely. It's not perfect. There is a compile step you have to build in and add. There is extra complexity to having this in place within your project. There are plugins that exist for Grunt and Gulp and Broccoli and whatever the next ridiculous build tool that we've created is. But everything is already there and available. And there's also a command line compiler that works really, really well and has a very simple JS config file that just works everywhere and will also hook into your IDEs to do all this kind of stuff. So it's relatively easy to do, but there is an upfront cost to that. And it does also slow down your feedback loop. You can no longer just write code and run it immediately. We found this is typically fairly quick, so we've got projects with a few hundred JavaScript files, and you're talking about 3 seconds, this kind of thing, from scratch, which is a reasonable amount of time. I can wait 3 seconds. But that is 3 seconds. Like, you're not going to be able to write stuff and immediately just hammer refresh, and that does disconnect you a little bit. There's also incremental compilation options, so you can set those up so it compiles the whole thing at the beginning and then it watches and only compiles stuff as it changes, which makes it quicker. But you need to play around a little bit with those. And you're generally adding complexity to your build system. It's no longer simple, write JavaScript, run it. There's another layer there, and that has downsides, particularly on small projects. Occasionally, you need to fight the type system. The type system is not perfect. Sometimes it will be a bit unsure about whether you're doing something that's a good idea, particularly if it's not a good idea, and you might have to essentially cast stuff to any You at that point, you've opted out, and it's very easy, but you need to be aware that sometimes that comes up, particularly if you're moving old existing JavaScript code bases where you've already done silly things, because that's how JavaScript works, and you're moving them to TypeScript. The easy way, rather than simply rewriting stuff, is to just turn stuff to any and then eventually think about building that in slightly more structured ways, or persuading TypeScript that it's a good idea. And finally, the main criticism that tends to get bandied around against TypeScript is that it is not that ambitious. It is extending JavaScript. It is building extra power, extra features, extra types on top. It is not rewriting it. It is not fixing everything that people might consider to be wrong about JavaScript. We're extending and building new power here while focusing on being a superset of JavaScript, allowing all the existing stuff, messy or not, to exist, and simply giving people more power and more options. If you're looking for a rewrite into something that is like another language that you used before, this is not going to be it. Dart, ClojureScript, all these kind of PureScript, all these kind of things are pulling in very, very different languages from a very different approach and solving lots of these problems if that's stuff you want to solve. There are also other options if this sounds exciting, but TypeScript for some reason doesn't. The Clojure compiler has been doing some of this stuff for a while, not particularly elegantly, but effectively similarly. So if you're already using Clojure particularly, just investing more in that and getting that sorted has quite a lot of value. That will do type inference, although not quite as well, and will do annotations, although you have to do them in this weird comment syntax and stuff, but is essentially functional, with the one caveat that it doesn't have the enormous tool support that TypeScript has. TypeScript's been going for 3 and a bit years now, and pretty much any tool you could possibly want to use, you can get to integrate it with it really nicely. Flow is very, very new, coming up from Facebook. Another type inference engine. It looks really good at type inference. It also already has JSX support because Facebook are kind of into that sort of stuff. It's still relatively immature, so I think they announced this at the end of last year, so it doesn't really have tool support. Notably, doesn't have definitely typed, so if you want to be able to hook into existing type definitions to infer from for all the libraries you're already using, it doesn't really exist, although they're looking at maybe just interpreting TypeScript into Flow, which is interesting. So this is going to become a very mature and very exciting option eventually, but is still fairly early days, unless you really need JSX support. And Babel, if you're already using Babel for compiling other stuff, Babel used to be an ES6 to ES5 compiler that has now become an everything-to-everything compiler and has pluggable compilers for all sorts of stuff. It's got a type-checking pluggable thing, and if you're already using a bunch of compile steps in there, then plugging that in is probably the easiest way to go. It, again, doesn't have the same tool support, doesn't have the same maturity, but is going to be easier to set up and get going with if you're already using that. So that's everything I've got for you. Hopefully this is somewhat convincing that maybe types are kind of nice and not the devil. I definitely think it's worth having a go. We've been running this on a couple of projects now at some reasonably large scales, and it's been delightful in every way, essentially. There's a little bit of setup cost, but the rest is lovely. And it's well worth a try. I highly recommend it. Before I finish, I should note that if you follow me on Twitter, I'll be sticking out the slides for this later, so you can go and take a closer look. And we are both recruiting and offering training courses. Thank you.
Thanks, Tim. Thanks for that. Just quickly, because we've only got about 10 minutes, so has anyone got any questions? Go, 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 go.
Hi. One of the criticisms that TypeScript has, minor one, is that the transpilations to ES6 of the standard ES6 features are not quite as accurate as Babel, which is the gold standard. Have you found this to be an issue in practice?
No, it's a short answer. Yes, you're right, and Babel certainly, in fact, if I bring up the compatibility thing, is miles ahead of everybody else, both on coverage and on being really, really good at this stuff. If that is your goal, Babel is far and away the right choice. If you just want to get ES6 features, and indeed ES7 features, Babel is a really good place for that kind of stuff. TypeScript is offering it more because it can, it's very easy, it's bringing in extra stuff, and it works nicely with the existing systems, particularly modules and classes. But yeah, it's not perfect by any means.
Okay. And the other criticism is that all types in TypeScript are implicitly nullable. Yes. So when your function says that you're receiving a number as a parameter, actually it could be a number or it might be null.
Yes.
Have you found that to be a problem in practice?
We haven't found it to be a problem. It is something that a lot of people say it would be nice if it didn't do. But it hasn't actually caused any problems. This notably is something that Flow does not do. And is part of why its inference engine is more and more powerful there. I mean, it's something that would have been a nice choice. I think they've done it primarily to essentially follow Java and C# and stay in the same kind of pattern and provide the same functionality that people from there would expect. It's not necessarily a good decision, but it's still better than JavaScript.
Thanks.
Is it worth running TypeScript just as well as or instead of ESLint?
Ooh, that's an interesting point. It will be better at catching errors. It requires more setup. There's a balance there. It depends particularly on how big and complicated your code base is going to get. And certainly if you're interested in investing more time in getting more and more structure and safety there, it's well worth it. You can't really do that as much with ESLint, and it will catch more errors. But it's going to be more complicated, whereas ESLint, you can pretty much just drop it in and drop in a config file and go, which is nice, especially on small stuff. Anything else?
Any more questions?
How do you deal with community code? So if it's written in JavaScript or CoffeeScript or anything like that, would you manually copy and paste it over, or how do you deal with that situation?
So you can just use other JavaScript, which is very nice. It needs to know that the types of the other JavaScript exist, which either requires you to just promise this variable exists and it has type any, and then you're done, or pull in type definitions with TSD, and then again you're done, and you get static typing for the whole library. If you're importing stuff through module systems, you need to be compatible with module system. So if you're importing Node modules, you need to be compiling to CommonJS, or require modules, you need to be running an AMD. The module system I haven't touched on here because it's quite complicated, but you write modules for TypeScript in TypeScript's own syntax, in its own structure, which is currently about to be ES6 properly. There's two at the moment, but one is being rapidly deprecated, and it's basically you write them in ES6 syntax, so it's nice and it's future-proof and it's the way that modules should be done. And then as you compile, you specify the output. So you say, I'd like to compile to CommonJS, and it builds looking for Node modules, and when it imports modules, it uses Node to do so. And it just works, and it also supports AMD and UMD and System.js and ES6.
Thank you.
It's pretty good.
Cool.
Cool.
So I'm going to have to pause questions there. If you've got any other questions, drop them in the Get channel. I guess you'll be available in there at some point.
Yeah, sure. Or on Twitter, or in the pub.
Oh, in the pub, yeah. Right, okay, let's so I've got a couple of quick slides just to finish up then. So can we give Tim a big round of applause?